All right, good morning. My name is Captain Wyvell. Today we're going to be going over basic map reading. All of you should have a practical exercise in front of you, as well as a map and a protractor at each of your tables. All right, so first things first, our learning objectives for today. We're going to identify marginal information on our map, topographical symbols, and the colors used on a military map. We're going to classify the 5 major, 3 minor, and 2 supplemental terrain features on military maps, and we're going to locate grid coordinates using a map. All right, so lastly, it's a little hidden down here, but why is this important? Why do we think it's important that we all have an understanding of map reading and navigation as officers and leaders? Sorry, go ahead, Callie, you first. Yeah, if we get lost. Why don't we want to get lost?
Because they might not find us. Safety.
Those are all good reasons. Yeah, safety. They might not find us. We might not find our objective. And as leaders, we're expected to lead our troops in the right direction, quite literally, right? All right, so with that in mind, we're going to do 2 quick videos demonstrating why it is important that we're competent in map reading. A little bit of a laugh at Captain Sobel's expense there, right? I'm not saying your soldiers would do something like that to you in the future, but if we're not confidently and competently able to lead our soldiers, it can lead to scenarios where our unit isn't performing optimally, right? All right, okay, perfect. Next slide, please. All right, so real quick, take out your phones. We're going to do a quick pop quiz from the reading that we did prior to this class. Back one. If you would just tab over back to the internet, and then the tab all the way to the right is the quiz, or excuse me, the QR code. Would you actually hit present, please, in the top right corner as well? Give it a second. All right, perfect. QR code, you guys know the drill. Any thoughts that you have that you remember from the reading? What are defining features of a map? What are the defining features of a map? Just anything you remember from the reading, or even just past experience that you might already have from map reading if you did, scouts or any sort of other outdoor organization.
Like the QR code, isn't it? Yeah. Want me to share it? Yeah.
Okay, so we have the key. Who wrote the key? What's a key, Polk?
So like it tells you what's on the map, like the little signs, the symbols and stuff.
Yeah, it's a way to read the symbols on the map, right? It's like the key to the test, right? Key to the code. Awesome, okay, the key. Compass, okay.
I just said that.
No, it works. We read a map with a compass. There's also a north-facing arrow, right, so that we know which direction is north, which direction is up on the map. So that's fair. A grid, awesome. What are grids?
Scaling lines, figuring out how far distances are.
There we go. The scaling lines, excellent. All right, so real quick before we press on, if 1 or 2 more come up, that's fine. But let's talk here. I have drawn a representation, right, of part of our campus. So we've got our ROTC building, parking lot, the stadium, football stadium, and then a road here with an intersection. Is this a map? This drawing?
Kind of. Yes. Not really.
Not really.
Not really. Why not? What up there is it? Oh, darn, now we got a lot of answers. Excellent. What up here is that map missing? There's two key ones. It is missing the grids, yep. And by extension, if it's missing the grids, what does the grid represent on the map? Scale, excellent. There's no scale on this map. There's no grid on this map. We have no idea if this is drawn to the correct size, right? Is the stadium really that big? It might be. I don't know. I just drew it, right? We have no idea if the stadium's that big. It's just a drawing. Also, we don't have any topographic symbols or a key for you to read what's on this map, right? But the key things there's no standard symbols used on this map, or on this drawing, I should say. It's not a map, and we're lacking scale. Those two things are key, because what a map allows us to do is understand where we are and where we're going, right? On a 2D surface of the map representing the 3D surface of the Earth. So if it's not to scale and we don't understand what we're looking at, we're not able to do that. All right, thank you. Sergeant Gatlin, would you hit the space bar? It should go to the next. Little quiz there. No, it's not Jen. Okay, if it's not Jenna, we can we'll just group share it instead of worrying about the QR code. Oh, there it goes. Okay, 5 major terrain features from your reading. Just throw them up there if you remember any of them. Hills, awesome. It'll get smaller, I promise. Valley, great. Yeah, that's okay. River, not quite on rivers, not quite. Water is important. What was your guess, Callie? Oh, okay, no worries. Saddle or depression? Okay, there we go. Depression's one. We're going to get to saddle. Do another like 30 seconds. Ridge. Who said ridge? There we go. Nice job, Mom Point. Ridge. All right, Sergeant Gatlin, you can close out of this if you don't mind, and take us back to the slides, please. All right, so we're going to go over all of these key terrain features. This was just a little jogger for the mind from what we read hopefully yesterday. But we're going to go over the acronym Hidden Valley Ranch Salad Dressing, and that'll equate to all of the 5 major terrain features, which we'll get to in a minute. All right, so before we start with that, we got to know what we're looking at on the map. So all of you have one at your table. I've got my map hung up here. So the first thing we have on our map is what we call the marginal information. So that's the information in the margin, so off of the graphical portion of the map. First one is going to be the sheet name. The sheet name is up at the top. Please note that the maps y'all have they show the same area, but are not exactly the same as the screenshots from this presentation here. So your map is the Fort Knox Special Training Areas map. It's specifically made for cadet summer training because it zooms in on the area where y'all will do your training after your junior year. So that's the name there. The sheet number, this one doesn't actually have one because it's a special created map. It's not part of the larger military grid reference system series of maps. But normally, you would have a sheet number assigned to each individual map, and you'll have the adjoining map sheets diagram, which is shown right there on the side in your marginal information. So what does this show, right? Well, sometimes we have operations that cross from one map into another, right? At some point, the paper has to be cut off because it'll be too big, but the real world just keeps rolling, right? So in order to know where we are, but also where we're going if we're moving from map to map, each map will have this diagram as long as it's part of the standard military map set. So you'll see here in the middle will always be the map that you have. So as this says, this one is for, this example is the Fort Knox military installation map. Here is the sheet number, Fort Knox SPEC, and you can see here it says Fort Knox SPEC. There's also a code designated to it as well. So if we were here and we were operating in a mission that required us to leave the top of our map, or the north of our map, this will tell us the code of the next map that's up to our north. So north, south, east, west, or diagonal, we can easily look up what map sheet we need, and then we can order them for our mission so that we have them with us and we can smoothly transition from one map to the other. Does that make sense?
Yes.
Cool. All right, next slide, please. All right, marginal information 2, we do have these. So one, on the side we've got notes. Perez, what do some of those notes say? Just read me the first couple.
The map may not meet NGA topographic line map production specifications. The normal railway gauge is 1.44 meters or 4 foot and 8.5 inches.
Okay, that's good from there. I'll jump up here to this one as well. You can see these are just notes about the map that we can use for measuring or doing whatever. So the biggest one, map does not meet the NGA topographical line map production specifications. That basically means that we can't use it for surveying because there might be a road that's slightly off and it shouldn't be used for like legal surveys or anything like that. But another important one to consider here, so a lane on this map, so a lane would be a road, a path, could be a paved road, something like that, is considered to be at least 2.5 meters or 8 feet wide. So because everything on the map is scalable to the world around us, you'll know that 2.5 meters is the width that all of the roads or paths are drawn on that map. Does that make sense? All right. So in short, it's just information about how the map is created and if there's anything we need to know about it, like, for example, we can't use this for legal surveys. We also have the declination diagram. The declination diagram goes over what we call declination, which is the change between true north, grid north, and magnetic north. We're going to go over all of that in the following lesson, but just know that between how north is shown on a map, because we have a flat piece of paper showing a 3D world, right? It's not going to be perfectly accurate to what us in the real world looking truly north to the North Pole would actually be like, right? Because these lines are bent over the span of the Earth. So that's grid north, or excuse me, that's true north, is the actual North Pole. Grid north will be slightly off. That's as close as we can draw straight lines representing the world on a piece of paper. And then magnetic north is the most important one. So if you look over here, I've got a very terrible drawing for you guys. This is the United States, right? So up here, not actually in the North Pole, but over central Canada is the point where the magnetic waves that are generated by seismic activity in the Earth, right, originate from. Those magnetic waves, those magnetic fields are what cause compasses to point north, basically. So, because it's not actually at the North Pole, it's somewhere in like north central Canada, we need to understand the difference between true north and where our compasses are actually going to point to. And it'll change where we are depending on where we are on the Earth. So for example, we're here in Houston, right? I actually don't remember off the top of my head what the declination difference between true north and magnetic north is for Houston, but it's really close. It's like a degree because we're just lucky and have this field directly north of us, right? But if you're at Fort Knox, you're over here, even though true north is up here, your compasses are going to point over here. So that difference between straight up and the angle is what's shown here on the declination diagram so that you can account for it when you're doing your actual land navigation, which again, we're going to get to more of in the following lesson. But I point this out to illustrate it because even though here, it's almost non-existent, it's like a degree, there is about a 5-degree difference. It's written on your map on the declination diagram in Fort Knox in Kentucky. And if we were out here in Fort Lewis, Washington, which is where we used to do cadet summer training up until about 10 years ago, now instead of true north being like this, your compass is actually pointing way over there. right? So it's important to always reference the declination and make sure you're taking it into account when you're on the ground, because if you were up here, you could be walking like 45 degrees off in the wrong direction, right? I don't know if it's actually 45, but in this depiction, it looks like it. Sound good? Kind of makes sense. Does that not make sense to anyone?
No, it does.
No? Okay. All right. Perfect. Next slide, please. Sorry about that. All right. So lastly, getting back to our map, our last bits of marginal information. So we have the scale. The scale is always here at the very bottom, and it's going to tell us what size this map is, because everything is proportional, right, to the real world. So on your map, what does it say for scale? Yep, 1 to 25,000. So 1 of anything on this map is equal to 25,000 in real life. So if you took a ruler, stuck it up here and said from here to here is 1 inch, that 1 inch on the map equals 25,000 inches on the ground if you were to walk it or put a ton of rulers end to end. So that's how we know, 1, our general size, but 2, on our protractor right here, we have these different triangles, which we will use to orient ourselves on the map and define specific grids later in the lesson. Each grid box is 1,000 meters square. So it's 1,000 meters from here to here, or from here to here. So if you ever have a 4-digit grid, all it's gonna do is tell you what that point you're looking for might be within 1,000 meters, or a whole grid square. It's not super helpful, right? If I said, let's go over to our example over here, we'll pick on Bajwa, I'll pick on you.
Okay.
So Bajwa's over here at ROTC, right? ROTC building. That's you, Bajwa. And he dropped his keys somewhere on the UH football field stadium and he needs to find them, right? Keys are down here. If I said, oh yeah, I know exactly where your keys are, they are, let's pretend it's this grid, they're at EH7800. That will give him a 1 square kilometer area to search in. Do you think he's gonna find his keys in a 1 square kilometer area to search in? No, right? That'd be ridiculous. You'd never find that. All right, so we need to make this grid more accurate. Next slide. All right, so this is demonstrating how we go to the 0, 0 point. This isn't gonna fit because the projector is not perfect, but we're lining up our 0, 0 here. And then what we do is we're measuring over, just like we do, we go right first and then up. So we can slide over, and then we measure up the side. Next slide, please. We'll get our numbers. All right, this will make more sense now. So now we're making our grid more accurate. Now we have EH, same thing, 785003. So for our mathematicians in here, if everything's in metric, right, and we know metric runs on scales of 10, we just went from a 1 kilometer box, which is 1,000 meters. How accurate is a box from a 6-digit grid coordinate? 100 meters. There you go. We're getting in closer. So to find 785,003, and bear with me because the size of the projector and this are not exactly the same. We put the edge of our protractor on the edge of that grid box that we found, and we're going to measure over by sliding this till the 5 lines up with the corner here. So, all right, so we're going to do our practical exercise right after this, but in closing, we identified the marginal information on our map as well as topographic symbols and the colors used on a military map. Classified the 5 major, 3 minor, and 2 supplemental terrain features. What was the silly way of remembering the major ones?
Something ranch. Hidden Valley Ranch.
Salad.
There you go.
Okay, shut off.
I wrote it down, sorry.
Hidden Valley Ranch salad dressing, yes, good. And we went over how to locate grid coordinates on a map, which we are going to practice right now. Before we go into practicing, does anybody have any questions about this? No? All right. All right, that concludes today's lesson.